Hey, grab me one too.
Every single day, more than 1 billion servings of PepsiCo drinks are consumed around the world, according to PepsiCo. That number means 1 in 8 people on Earth is drinking something made by the company. Inside its factories, 6 production lines can fill up to 36,000 bottles of Pepsi every hour. The air hums with the sound of pumps, chillers, and pressurized CO2 systems working in perfect rhythm. It's a drink so familiar that most of us never stop to ask, how does this dark, fizzy liquid travel from underground water and secret syrup to the ice-cold bottle in your hand?
Now put your hour on this, 'cause I put it down.
Pepsi's story began in 1893, inside a small drugstore in New Bern, North Carolina. The pharmacist Caleb Bradham created a caramel-colored drink that he first called Brad's Drink. His goal was simple: make a refreshing tonic that could help with digestion. 5 years later, he renamed it Pepsi Cola, inspired by the word pepsin, an enzyme linked to the stomach. At the time, every bottle was hand-filled and sealed one by one. But by the early 1900s, the rise of automated bottling lines changed everything. Factories could now fill hundreds of bottles per minute, turning a local pharmacy recipe into a household name. Over the next century, Pepsi evolved with every generation, from glass bottles to cans, and now eco-friendly PET lines. Yet its core idea never changed: a mix of sugar, caffeine, and fizz that made it a part of American culture. So, how does a 130-year-old recipe still power one of the fastest production lines in the world today? Everything starts with water. At the Pepsi plant, the source water is pumped from deep underground wells, sometimes more than 800 feet below the surface. It passes through several filtration stages to remove minerals, chlorine, and any organic matter. First, carbon filters absorb unwanted odors. Then, fine membranes remove microscopic impurities. Operators monitor conductivity and pH every few minutes to maintain exact standards. In another section of the factory, massive stainless steel tanks hold the ingredients that form Pepsi's syrup. Workers pour in sugar, caffeine extract, and a carefully measured concentrate shipped from one of Pepsi's top-secret facilities. Each batch is blended according to a strict recipe that includes lemon oil, vanilla, and caramel color. Sensors inside the tanks measure Brix levels, which represent sweetness, while automated valves adjust the ratio of syrup to water in real time. Every 10 minutes, lab technicians take samples to check color and aroma. The smell inside this room is unmistakable: sweet, rich, and sharp with caffeine. Once the syrup passes all tests, it's pumped to the mixing unit where water and carbonation meet. The chilled water and concentrated syrup now merge in a high-pressure carbonation unit. Inside, precision injectors pump CO2 into the liquid, while powerful mixers ensure even distribution. The pressure inside this chamber can reach 75 pounds per square inch, forcing the gas to dissolve completely. The colder the liquid, the stronger the fizz, so the system maintains the temperature around 1 degree Celsius. A slight hiss fills the air each time a valve opens to release pressure. This stage determines Pepsi's signature sensation: the light tang on your tongue when bubbles burst. Operators use CO2 analyzers to check gas levels in every batch, keeping them consistent to within 0.1%. In total, the carbonation process can handle up to 36,000 bottles worth of soda per hour. It's a delicate balance of chemistry and engineering. Now that the Pepsi mixture is ready, how does it reach the bottles without losing its sparkle? Each bottle begins as a small plastic tube called a preform. Machines heat the preforms to about 110 degrees Celsius and blow them into shape using compressed air inside metal molds. Within seconds, they expand into full-size bottles and cool down under water jets. Every bottle then travels through an automatic rinser, ensuring no dust or debris remains inside. The filling station uses synchronized valves to pour exactly the right amount of Pepsi into each bottle. The process runs at lightning speed, up to 600 bottles per minute on one line. Caps are placed and sealed tight to keep carbonation locked inside. Next, high-speed labeling machines apply the familiar blue and red Pepsi label at perfect alignment. Quality sensors check every bottle for correct fill height and seal strength before sending them forward. So once every bottle is filled and sealed, what ensures it stays fresh until you open it? Before leaving the factory, every batch of Pepsi goes through multiple quality checks. Technicians measure CO2, concentration, sugar level, and pH in the lab. Random bottles are tested for pressure resistance and storage stability. Any sample that fails is immediately traced back by barcode to its production line. After approval, bottles are grouped in trays or shrink-wrapped into packs of 6, 12, or 24. Robotic palletizers stack the boxes neatly for shipping. In large facilities, up to 150 trucks depart every day, carrying fresh Pepsi across the country. Inside each bottle, the fizz you hear is the same one that began deep inside those mixing tanks. It's the sound of precision at work, repeating millions of times a day. And the next time you crack open a cold bottle, can you imagine the journey it took to get there? Every single hour, one Frito-Lay factory can produce nearly 4 tons of potato chips. That's over 750 tons of raw potatoes, sliced, fried, and packed every day, according to PepsiCo. Each potato takes a journey that lasts less than 24 hours, from farm to fryer to bag. Inside these facilities, machines wash up to 6 million potatoes a day, cut each one into 0.06-inch slices, and fry them in oil at around 350 degrees Fahrenheit. It's a non-stop rhythm of steam, oil, and golden color. Yet most of us never think about what happens before we hear that familiar crunch. So, how does an ordinary potato transform into one of America's most irresistible snacks? The story of Lay's began in 1932, when a traveling salesman named Herman Lay started selling homemade potato chips from the trunk of his car in Nashville, Tennessee. His chips quickly became popular, and by 1939 he opened his first factory, producing small batches packed by hand. After World War II, automation changed everything. Conveyor belts, slicers, and fryers replaced manual labor, allowing mass production on a scale never seen before. In 1961, Lay's merged with the Frito company to form Frito-Lay, which later became part of PepsiCo's snack division. This partnership gave the humble potato chip a global reach. Today, Frito-Lay operates more than 30 production plants across the United States, delivering chips to over 200,000 retail stores. Yet despite the scale, every chip still starts with a simple potato, sliced thin and fried golden. So how does that single potato survive the heat, speed, and precision of one of the fastest snack factories in the world? The journey of a Lay's potato chip starts in the field. Special harvesting machines dig deep into the soil, lifting potatoes, roots, and dirt all at once. A vibrating conveyor shakes off excess soil while sorting through up to 40,000 potatoes per minute. Trucks drive alongside the harvester, collecting fresh potatoes without stopping the operation. Once full, they head to large storage hubs built to hold hundreds of tons of crops each day. At the factory, the potatoes are unloaded and sent through a massive washing system. High-pressure water jets, soft brushes, and a swirling rinse remove every trace of soil. This industrial washer can clean nearly 6 million potatoes a day. The clean, firm potatoes then pass a final manual check, where workers remove any damaged ones. Each potato must meet strict standards before moving to the next stage. But how do factories peel millions of potatoes without damaging their texture? The clean potatoes roll into powerful abrasive peelers. Inside, rotating drums lined with gritty surfaces spin rapidly while jets of water spray the skins away. The process takes only a few seconds, but must be precise enough to remove the thin outer layer without cutting too deep. The peeled potatoes are then scanned by optical cameras. These high-speed sensors detect imperfections, bruises, or dark spots in milliseconds. A quick puff of air removes defective potatoes from the line. The good ones continue towards sorting belts, where they are separated by size. Oversized potatoes are automatically sliced in half to ensure uniformity during cutting. Workers stand along the conveyor for one last human inspection, removing any that machines might miss. The goal is consistency. Every potato must cook evenly in the fryer. Now that the potatoes are ready, how do they transform into those paper-thin slices we know so well? The prepared potatoes enter a centrifugal slicing drum, spinning at incredible speed. Sharp stainless steel blades slice each potato into 0.06-inch pieces, exactly the right thickness for a Lay's chip. Quality control teams constantly check the thickness, since even a small variation can change the final crunch. The slices are then washed again to remove excess starch, preventing them from sticking together. After drying, they drop into a 40-foot-long continuous fryer filled with hot oil. The temperature is carefully maintained around 350 degrees Fahrenheit, and each chip fries for about 3 minutes. Sensors track oil quality and temperature, while a 50-50 mix of fresh and recycled oil gives the chips their signature color. Steam escapes as the slices crisp up, replacing moisture with oil. Vibrating conveyors move the fragile chips forward gently, keeping them intact. Once golden and crisp, how do factories make sure only perfect chips reach the bag? After frying, the chips enter an optical sorting system that scans over 400 slices per second. Any chip with brown edges or uneven color is blown off the line by precision air jets. The remaining chips tumble into a rotating seasoning drum. Salt or flavored powders, like barbecue or sour cream, are evenly dusted as the chips spin. Since the chips are still warm, the seasoning sticks instantly. Quality testers pull random samples to check crunch, flavor, and color. Specialized machines measure oil content and moisture to ensure every bag tastes identical. Each batch must fall within strict limits before packaging. The air smells warm and savory, filled with the scent of cooked potatoes and spices. This is the stage where the snack gains its final identity. So once the chips are perfectly seasoned, how do they stay crisp inside every bag? The finished chips move to the packaging floor through a vertical conveyor system. Here, a multi-head weigher calculates the exact amount for each bag, adjusting the flow within grams. Bags are formed from rolls of printed film, sealed at the bottom, and filled with chips. Before closing, the machine flushes the bag with nitrogen gas to replace oxygen. This prevents spoilage and keeps the chips from breaking during transport. Each bag is then heat-sealed, coated, and passed under a camera for inspection. Cartons of chips are packed, shrink-wrapped, and loaded onto pallets. Robotic forklifts stack them for shipping, sending thousands of bags out every hour. Frito-Lay trucks deliver to supermarkets, vending machines, and gas stations across the country. Next time you open a bag and hear that soft hiss of nitrogen escaping, will you think about the factory precision behind that crunch? Every year, Americans eat more than 1.3 billion gallons of ice cream, according to International Dairy Foods Association. That's enough to fill nearly 2,000 Olympic-sized swimming pools. But imagine if that classic frozen treat could also fizz like soda. Inside a handful of modern factories, engineers are doing exactly that, combining the creamy texture of ice cream with the sparkle of carbonation. The result is a dessert that crackles on your tongue and melts like silk. It's part chemistry, part craftsmanship, and it all depends on timing, pressure, and temperature control. So how do they trap soda bubbles inside something frozen solid without losing the fizz? The idea of frozen desserts with bubbles dates back to the early 20th century, when soda fountains were a central part of American culture. Back then, Soda jerks mixed fizzy drinks with scoops of ice cream to make ice cream sodas, a treat that became a symbol of summertime joy. But it wasn't until the rise of modern refrigeration in the 1950s that factories began experimenting with frozen carbonated desserts. Engineers discovered that CO2 could be infused into semi-frozen mixtures under pressure, creating a light, sparkling texture. This concept evolved alongside continuous ice cream freezers, which allowed for better control of air and gas content. Today, the soda ice cream blends old-fashioned nostalgia with modern food technology, using the same principles found in carbonated slush machines. It's a delicate balance of science and sweetness. So how do factories actually freeze soda without losing its fizz? The process starts in the mixing room, where tanks hold milk, cream, sugar, and milk solids. Workers measure each ingredient to exact ratios, following recipes standardized under FDA's Grade A Pasteurized Milk Ordinance. The mix is heated to about 85 degrees Celsius for pasteurization, destroying bacteria and dissolving sugar evenly. Next, it passes through a high-pressure homogenizer, which breaks down fat globules into tiny droplets. This gives the ice cream a smooth, creamy texture. The mixture is then cooled to around 4 degrees Celsius and transferred to aging tanks, where it rests for 4 to 8 hours. This step allows stabilizers and emulsifiers to fully hydrate. Continuous sensors monitor temperature and viscosity to ensure consistency across batches. By the end of this stage, the ice cream base looks like thick milk, ready to be frozen and aerated. So what happens when this chilled mix meets freezing steel and pressurized gas? The cooled mix enters a continuous freezer, a stainless steel barrel lined with rotating blades. Inside, the temperature drops to around -5 degrees Celsius. The blades scrape frozen crystals off the wall while air is pumped in, creating what's known as overrun. Overrun is the amount of air added to give ice cream its light texture, usually between 50 and 60%. Too little, and the ice cream turns dense. Too much, and it collapses quickly. Operators monitor pressure gauges and airflow meters, ensuring every batch meets exact density standards. Within minutes, the liquid turns into a soft, semi-frozen product similar to soft serve. This is where the magic of texture begins. But for soda ice cream, one more element is about to change everything: carbonation. How can factories inject bubbles without freezing the soda flat? This is the step that turns regular ice cream into a fizzy dessert. Engineers introduce CO2, or pre-carbonated soda syrup, directly into the semi-frozen mix. Using a high-pressure variegator, fine bubbles of gas are blended into the base while the temperature stays near -8 degrees Celsius. The pressure prevents the gas from escaping, locking thousands of microbubbles inside. The soda syrup adds flavor: cola, root beer, or orange, while the gas gives the ice cream its sparkle. Too much pressure could burst the mix, too little, and the fizz disappears. Real-time sensors record carbonation levels to within 0.05% accuracy. Once the swirl of soda and cream is balanced, the mixture flows smoothly toward the filling machines. Now that the dessert is both frozen and fizzy, how do factories keep it that way until it reaches the freezer aisle? The soda-infused ice cream is dispensed into cups, tubs, or pints through automatic filling nozzles. Each filler deposits an exact weight before sealing the lid. The containers then move to a hardening tunnel where powerful fans blast air as cold as -30 degrees Celsius. The rapid chill freezes the product solid without allowing ice crystals to grow too large. This step is crucial for texture. Faster freezing creates smoother ice cream. Conveyor belts carry the product slowly through the tunnel, giving each one equal exposure to the freezing air. When they emerge, the tubs are firm and frosty to the touch, ready for inspection. Machines print production codes, while operators check lid seals and label alignment. But even when frozen, soda ice cream needs special care to stay fizzy. How do factories protect that carbonation from leaking out? Every batch undergoes strict quality testing before shipping. Technicians measure fat content, air overrun, pH, and CO2 concentration. Samples are stored for shelf life tests to check texture and fizz stability over time. In the storage warehouse, the temperature is maintained around -20 degrees Celsius to prevent gas loss. Palletized loads are moved into refrigerated trucks that keep the same cold chain from factory to retailer. Each tub carries a code that can trace it back to the exact production line and time of day. This ensures total traceability if a problem occurs. From there, the fizzy frozen treat begins its final journey to grocery freezers and dessert shops across the country. The next time you scoop a spoonful and feel that gentle tingle on your tongue, will you remember the science hidden beneath its sweetness? From soda to chips to ice cream, each product we've explored today tells the same story of precision, innovation, and memory. Inside every bottle of Pepsi, every bag of Lay's, and every scoop of soda ice cream, there's a hidden world of machines working with incredible speed and accuracy, turning raw ingredients into something familiar on our shelves. What began as small experiments in kitchens and pharmacies has become a global operation measured in tons, gallons, and megawatts. Yet, no matter how advanced the process becomes, each one still connects back to something simple: taste, comfort, and nostalgia. These are the flavors that shaped childhoods, filled lunchboxes, and defined generations. The next time you pop open a soda, open a bag of chips, or dig into a frozen dessert, you'll know the science and craft behind it. If you enjoyed this journey through the factory floor, don't forget to like this video, share it with a friend, and subscribe to Captain Discovery. Stay tuned for more stories about how everyday things are made, and join us next time as we uncover another secret behind the products you love.